So in the sensor assignment of the previous section, we have built the sensor application using concrete classes and inheritance. So basically this is what we have done in the previous one. We did sensor, okay, here we call it sensor IMPL, and we have distance sensor that extent sensor and air quality sensor that extent sensor. This is what we have done in the previous assignment. Okay, we have only used inheritance. But in this assignment, we would like to use contract first approach for the development. And this means we will start by developing interfaces and then implement these interfaces into their classes. So let me clarify something here. We have made the name of the concrete class as sensor IMPL. So we have added IMPL at the end. This is one approach. So one approach is to do the following. For example, the interface is called sensor and the class, okay, sensor IMPL. For example, if I have an interface, for example, student, the class will be called student IMPL. There is another convention that probably can come also in the major exam, is that for the interface, we will use the letter I in the beginning. For example, I can say I sensor. Okay, in this case, I will name the class as just sensor like this. I can do the interface as I student, and the class will be student. So these are two conventions that you can find. Okay, either we add IMPL into the concrete class, or we add the letter I in the beginning of the name of the interface. So I, it means interface. Okay, so in this assignment, we're going to use this convention where we use the name of the class or the simple name for the interface, and we add IMPL for the implementation. Just to clarify this, let me increase the size. Okay. Okay, Open NetBeans package provided to you, and first a quick at the initial code provided in the packages. So usually we provide you an initial code, which is this one, iot.op.core. So core here will be used to provide the class implementation, and interfaces, this is another package that will be used to create the interfaces. Okay. Let's start by the first question. So usually in contract-based development, we start by developing the interfaces. First, we will start with building the interfaces for the Internet of Things application and specify all the operations first. We will consider some changes with respect to the previous quiz 02. The relationships between the classes interfaces are the same as in quiz number 2, as in the previous assignment. In what follows, we present the interfaces and their methods. So you have two main packages, iot.app.interfaces. This will be used to write the interfaces, and iot.app.core will be used to write the class implementations. Now the first interface is called the interface measurable. Define an interface measurable object. Measurable must be comparable. It has a method value that returns double, and it has a unit that returns a string. So here we're going to go to interfaces and create a new interface called measurable. So measurable must be comparable. So what we will do? Extends comparable. And here pay attention, you have to specify the type. Okay? Usually if we don't specify comparable to what, it must be with the same class. And here, value and unit. Value will return double, and unit returns a string. Okay, public abstract double value, and public abstract, what is the type? String unit. So every measurable, and this has actually some meaning, because we mean every measurable object has a value and has a unit. For example, temperature is measurable. It can have a value, for example 25, and unit, for example, degrees or Fahrenheit or something like this. So this interface captures everything that can be measured, and everything that is measured must have two information, value and unit. So this is for the first interface. Okay. Now what you can do to save time, whenever you complete something, you can just take it and copy it in the right place. So you have already done. And then move to the next question. Now we will develop the interface sensor. Let me take all of this. I'm going to create a new interface here. Sensor. Define an interface for sensor object. A sensor object is measurable, so here I will do extends measurable. It has a method getID that returns a string which represents the ID of the sensor. So public abstract string getID, and then public abstract string getName, and public abstract string getBrand. That's all. And measurable here, sensor, that's fine. So I can remove all of this. Now I can take that and put it over here. Is it fine? Now we move to the next interface, Interface Wi-Fi. So we do the same process. Come here, define a new interface, it's called Wi-Fi. Define an interface for any Wi-Fi wireless. It has a method getIP, public abstract string getIP, and public abstract string getSSID.
What is SSID? What is SSID?
So usually when you connect to a Wi-Fi network, okay, it has, every network has a name. So the name is called SSID. Let me just show. I hope I can find the name here. Let's first connect. So the name of the network, this is called the SSID. Okay, if I go to advanced here, okay, it's not shown as SSID, but actually this is known as the SSID of the network. All of these names are called the SSID. And the IP is the IP address.
Sir?
Yes?
In the first one, when it says define the interface for any wireless Wi-Fi object,
Yes.
so does that mean it's going to be implemented in every Wi-Fi class?
Of course. Now if we are doing the interfaces here, is to implement them later on. So for every class, you have an abstract type.
Yeah.
Okay. Okay, so now we are done with Wi-Fi. And finally, we have node, interface node. New interface node. Define interface for node object. It has a method getSensor, public, which returns a list of measurable objects. Look now, we're going to do abstract list measurable get sensors. No problem. You can do. You can do. And then get Wi-Fi. It returns Wi-Fi object. So every node, look now, when I see the interfaces, I can understand. Every node has a list of sensors and has Wi-Fi to connect with other nodes. Okay, so you can see how the abstraction, it gives you some semantics, some understanding of the classes. Okay, this is why we do that. Okay, so here Wi-Fi, get Wi-Fi, and that's it. Now, let me copy this into here. Now we are done. These are 4 easy points. Now you will complete the missing code in the classes provided to you in the package iot.app.core. Let's start by the sensor IMPL. So here we have the class sensor IMPL. So first of all, it's an abstract class, but it doesn't have any implementation of the interfaces. So in the beginning, I think abstract probably could be removed because there is no abstract method here. First, yes, sorry?
But we have to implement from another interface. So
yeah, for the moment, in principle, I should give you the class without abstract like this because there is no abstract method. And now, read the class sensor IMPL. First, complete the missing code in the declaration of the class to implement the right interface and add the missing methods. So, what interface we should add here?
implement sensor.
Implement sensor. Implement sensor, yes. So here we have an interface sensor. We need to implement here. It's clear. Okay. I should not say you have to implement the interface. It's clear. Now you have an interface, and then I will make that as sensor. So what we will do here? Sensor, first of all, we need to import sensor because now they are in 2 different packages. Okay, so first of all, what you have to do is to import because sensor is in a package different from sensor IMPL. So it's not directly visible. So first of all, we need to import. After importing, of course, here we will have sensor IMPL is not abstract, does not override the abstract method. So what abstract method we do have here? Get ID, get name, get brand. We have get ID. So we can write override here. We have get brand. Get what? And sensor also we have get name. So what things are missing now? This is get name. So we don't forget that sensor is measurable, and measurable has already 3 methods compared to value and unit. Okay, so look now. Sensor A. Now here we give you how to make comparable. But before comparable, what do we have? So first of all, we have set value. Okay. Now we have to implement all the methods. Implement all abstract methods. We come here, we implement all abstract methods. So we have three abstract methods to implement. صح ولا لا? Okay. 3 abstract methods to implement. You have to implement. So value now, what we have to return? We have to return the value here. Okay, so I'm going just to return value. That's simple. And unit. Do we have unit here?
No.
We don't have unit. Because the unit of the sensor will depend on its type. So I cannot decide. If it is temperature, it's Fahrenheit or Celsius. If it is humidity, it's in terms of percentage. Okay, so here we cannot define unit. So since we cannot define unit, what we will do? We make this as abstract. If you don't make this as abstract, you have to define unit method. So you can make, for example, something return not available or any dummy value, but this is better. Okay, this is better. Instead of returning a dummy value, we do abstract, and here we have to override for the measurable.
So it's fine if we didn't put unit here.
In principle, you should not put unit. Do you have any unit defined here?
No.
So for the value, you have already an attribute. For the unit, you don't have.
So in our command,
Yes, yes. So now for distance sensor, we have unit here. Okay, we can write the unit later. Okay, so but for sensor IMPL, we don't have any value for the unit. So if you put unit here instead of abstract, you have to return something. Okay, return not available. But instead of doing that, which doesn't make sense, okay, we have said that if we don't know what value to put, in this case, we keep the method as abstract and define the class as abstract. What makes more sense? This one. Okay? But from programming point of view, you can also set some dummy value, but it doesn't make too much sense, okay, in software development.
Professor,
Yes?
if when I first start a class, I pick the option of implement all of the methods because it implements. Will it make a new get ID, get name, and get run? Or
No.
will it just override the old
It
one?
will not. It will not.
So it will just
Because they are already defined. It will only override the ones that are not defined in the class. Okay.
For the ones that are already defined, do I have to, for the ones that are already defined, do I have to write override?
No need. But it's better. Okay, so now you have to make comparable. Okay, and here you have to pay attention for this comparable, and you will see why. Okay. So here we give the comparison criteria between both. Sensor A is smaller than sensor B if the value of sensor A is smaller than the value of sensor B. That's very simple. Okay, so the value is what? Is double. We will do if this dot value is greater than m dot value. So here I don't need to make any casting because measurable has a value and sensor has a value. So I can just use the following. Return 1. Else if smaller, return -1, and finally return 0. Is it clear? So very simple. We are going to compare the value of the current sensor and of the measurable. So sometimes, if for example, I tell you compare with respect to the brand. In this case, M doesn't have a brand, so you have to cast. But in this case, M has a value, and the current object has a value, so you can make the comparison without any downcasting. Okay, so this is the comparison criteria between two sensors. We compare their values.
Victor, can you repeat the question I'm taking there too?
Which question?
This one.
Yeah, so this is the question. Sensor A is smaller than sensor B if the value of sensor A is smaller than the value of sensor B.
Yes, it's smaller, but you put three conditions: bigger than and equal.
Yes.
Professor, I have a question.
If A is greater than B, we return 1. If it is smaller, we return -1. Otherwise, we return 0. This is what we mean. Okay.
I don't understand why in the case of brand, if we ever compare brand, we have to make instance of, but in this case, no need to.
Here we have measurable.
Yes.
Do you have brand in measurable?
No.
So what you have to do?
Oh,
Okay. Okay. So now we are done with sensor IMPL. So, but look now. When you respond to the question, do not copy all the code of the class, only the changes. So please make my task for evaluation easier. Because if you copy everything, it's going to be too much. So what we will do, what are the changes? I have changed this one. So I'm going to copy. I will copy here. And then what are the other changes?
The last yeah,
Yes.
the public value and the
So I have added value and override. Okay. This is value. And this is compared to.
Also, you override the name and
Yeah, if we want, we can add the name as well. It's not. Okay, the override things here. That's possible. But they are already defined. I mean, these are the three things that you have to focus on. Public abstract. So this is here abstract. Here you have implement sensor. Okay. And then you override the value. And you do compare to. Who did that correctly? Okay. 2, 3, 4. Okay. IoT node. Write the class IoT node. The class has an array list of measurable object called sensors. It has an attribute of Wi-Fi object called Wi-Fi. Write the class with the requirement above. Okay, so now I'm going to create another node which is called IoT node. Let me take the requirements. Write the class IoT node. The class has an array list of measurable objects. So what is here? We have a class node, and here we have the class IoT node. So here we have to implement node. That's obvious. And I need to import node from interfaces. Then public. So the class has an array list of measurable object. Array list of measurable called sensors. Equal a new array list of measurable I need to import array list and I need to import measurable interface. Then it has a Wi-Fi object. Wi-Fi. And of course I have to make private here and private here. Write the class with the above requirements. So we can do a constructor. So usually in the constructor, we don't initialize the array list. Array list is usually put something empty. Okay, I need to import the interface Wi-Fi.
I have a question. Can we write, for the first one, and the array list measurable, can we write everything before the equal sign? Just declare it?
Here?
Yes.
What do you mean?
What if you delete this?
Yes, you can, but you run into the risk of having null pointer exception. Because if you do like this, you have in this case to create sensors inside the constructor. Okay, if you don't create inside the constructor, this object will be null, empty, not even create in the memory. So if you want to add anything inside of it, it's going to have null pointer exception. I will come to you in one moment. Okay, so it's safer actually to initialize this in the beginning, so you don't run into the problem of null pointer exception. Yes?
So I recall you told me the opposite, that we should just declare, like we usually just declare and then initialize after.
It's possible, yes. If you do that, okay, if you do that, you have to do it here. And you have to do it in every constructor.
Yeah.
Okay? You can do it here, it's not wrong. Okay? But in this case, for example, if you do another constructor, like for example, an empty constructor like this, okay, in this case, you have to do it again.
Yes.
What I told you do not initialize as a parameter.
Yeah.
Okay, like putting a new parameter here. We don't actually use this kind of assignment for in the constructor.
Certain how will you set, like
Yes, in the beginning you just set it to an empty array list, and then you can add some values if you want. Okay, it's not common to have something already filled in array list that you would like to put into an object. Okay, but if you want to write a smaller line of codes, you can do the following. In this case, you have to do it only once when it is created. Anyway, so there are different options. And here, what we have to do, implement all the abstract methods. So here we have list of return sensors. And here we will have to make return Wi-Fi. Of course, you have to do also insert code. We have to make getter and setters.
Maybe you only make setters.
I don't know, it's not inserting. Okay, I'm going to write this manually. Public void set sensors, and here I will have to provide. So I'm going to use list here. Has to be the same sensors, and this dot sensors equal to sensors. And here we have public void set Wi-Fi and this dot Wi-Fi is equal to Wi-Fi. Yes.
Go back to the question, please.
Go where?
To the question. How you know that you want to implement from node interface?
Because we have an interface node and we have here the class IOT node. So you have to understand this relationship. I don't have to say explicitly. Okay? If I have defined an interface sensor, it means it must be implemented here. Okay?
So every class should implement from.
In principle, yes. When there is a confusion, I have to say. But for example, node and sensor, it's clear. It's clear. Okay, now the function must be done in the class IoT node. Now what we will do, look, we have made IoT node and we will do some more code after that. Don't copy all the code, including all the questions. Just for this question, we copy its code here. So alert, although it's going to be inside the IoT node, you copy it as a different function. Yes. So the function must be done in the IoT node. Write the method alert, which returns a boolean. It returns true if any of the following conditions is satisfied. Okay, I'm going to take all of these here. And just below, so public, it returns a boolean, and alert, it returns true if any of the following condition is satisfied. The value of any distance sensor inside the sensors list is higher than the threshold. I think there is something wrong here. Yeah, we have unit here, okay. Okay, so now what do we have? We have a list of measurables. And this measurable, it can be a distance sensor, it can be an air quality sensor. Okay, so of course, this is now we will do polymorphic processing. We're going to go through all the elements and we will see if it is an instance of distance, we'll check the distance value. If it is an instance of air quality, we will check the gas value. Okay, so this is the algorithm. Okay, for every sensor inside sensors list, check if it is a distance sensor, then check the value of the distance. Then, if not, check if it is an air quality sensor. In this case, check the value of the air quality. That's it. So how to do that? We can make for each statement, for every measurable, M inside sensors. Okay, check if it is a distance. So how to do that? If M instance of distance sensor, so now we are here. Okay, else we can also do the second part if it is air quality sensor. واضح? So first of all, write everything or your conditions. Now we will check here. First of all, we need to create a distance sensor. ds equal, what we will do? We will do a casting on M. And then if ds dot get range is greater than, sorry, get value, it's the same as range here. Okay, here we have alert threshold.
No, the method is empty, but you can.
Yeah, we can do here a double alert threshold.
Or you can put distance sensor dot. It will appear.
Mm-hmm.
You can put now distance sensor dot alert instead of
Yeah.
we put
Just a moment. We did not define alert threshold before.
No, doctor.
Okay, I'm going to define an alert threshold. I thought it is defined.
Yes, doctor, you can write distance sensor.
Okay, no problem. I'm going to do that. So if it is greater than alert threshold, return true. Because the first time it's going to find it, is going to return true. And you can do even an alert threshold for the distance. Distance alert threshold. One moment, please. Distance alert threshold here. And the other one is air quality alert threshold. AQ. AQ. Okay, and this one air quality. So we will do air quality here. Casting to air quality. AQ. And here we have AQ.getValue greater than we return true. If we don't return true after all the values, in this case we are going to return false. واضح؟
Instead, if we write the parameter, we can cast it, then we write dot alert 3. How that will appear in both.
We have here alert threshold. Okay, yes. So yeah, it's defined here. Okay, right. Yeah, I just forget about that. Okay, yes. So the right way to do it. Yeah, the right way to do it is actually to do. We don't do these things here. Yeah, it's here ds dot alert threshold, and here it's aq dot alert threshold. Yes. Yeah, this is the right way on how we can do it. Okay, and now we can put this into here. So we still have two methods to complete. We will do that tomorrow, and also we will complete the matrix exercise.
Professor,
Okay, so now we have the method read. This function must be done in the class IOT Node. Write the method read, which reads a file and extract all information about air quality sensor, distance sensor objects, then adds them to the sensors array list. Refer to the file sensors.txt that is provided to you. So we have this file. I'm going to take this file. Okay, I'm going to call it sensors. So let me go to the project. And here I'm going to call it sensors.txt. This is our file. So we have different lines. Okay, every line contains information about one of the sensors. Of course, here, if it starts with A, we know that it is air quality. If it starts with D, we know it's distance, and so on. We have two types of sensors. Okay, we're going to parse the file. You know what is parsing? It means we read line by line, and every line we extract all the words, and then we identify the words, assign them to attributes, and store them into an array list. Okay. Let me just take the file in front of me here. This is the file structure. And we will do a method public void read. So, of course, to read, we need to create a scanner. Okay. Scanner equal new scanner. And here we have a new file. Does it specify the text? Okay, so sensors. We can do here if we want string file name. So we specify the file name here. And then we have to import scanner. We have to import file. And you have to make a try catch. Okay. Of course, now we have access to the file, while there is all still next line has next line. We're going to read line by line. Okay, so string line equal sc dot next line. And then we have to split. We did this exercise several times before. Okay, we have to split. We're going to have an array of string, okay, that we call words, okay, and then line dot split, and we have semicolon. Then we are going to read one by one. So string id equal words of 0, and then we will check if the id contains a or start with d. Okay, if id dot start with a, so this means it is air quality sensor. صح ولا لا؟ okay, else if id dot start with d, it means it is distance sensor. Is it clear? So here what we will do, we will create air quality sensor AQ. Okay, so we're going to read the values as what? Let's see the attributes. We have value unit and the ones in sensor. ID, brand name, value. ID, brand name, and value. Value here is repeated twice. ID, brand, name, and value. So we start with the ID. We can make string name equal to what? Words of AQ, AQ1. This is 1. This is the name. Brand, string brand, words 2. 1, 2, 3, this is the value. So this is double. Value equal. Okay, double dot, parse double, words 3. And finally, the unit string unit equal words 4. Then air quality. So we will do, okay, air quality equal new. First of all, we have to create a new air quality sensor, okay, with ID, name, brand, value, and unit in the same parameters here. Okay, same parameters. And then we have to add this one into the array list. Finally, we do what? Sensors dot add AQ. And then we will do the same with the other one. Okay, so here we have ID. We have here name, brand. So yes, what do we have here? 1, 2, 3, 4, 5, 6. This is the brand. What is this value? This is the real value, the minimum, the maximum.
Yes.
Okay. Yeah. So let's take this one. So what we will have? This is the name. This is the brand. This is the value. and then you have max range. Okay, we will do, this is mean, start with mean for, and then this is double, this is max 5, and we have unit equal words 6 here. Okay, and then here we have to do distance.
But we have to read the ID again.
Distance sensor. Now the ID here, we have read the ID here. Index 0 here, ID. Okay, equal a new distance sensor. And then you have to look at the distance sensor here. We have ID brand name range. ID brand name, then the range, real value, and then mean max unit. So we have mean range and max range and unit. That's all, and finally we add DS. Okay, so this is all about the method read. Take this method and then we copy it here.
I did it with the throws exception, not try catch.
It's better to use try catch.
It's okay.
Yeah. In case of exception, you will have, it will exit the program in this case. And finally, we will do the write. Public void write string file name. Okay, in this case, we're going to make file writer fw equal a new file writer new file, and then file name. We import the file writer and then use try catch. Okay. So what we will do now, for every value of the sensor, for every sensor S, or it's measurable, for every, it's a array list of measurables, okay, for measurable S in sensors. What we will do, we will check whether it is a distance sensor or air quality. If S instance of distance sensor, we will process it. Else, if S instance of air quality sensor, we will do another processing. Is it clear? Okay. So what we will put here? Now we have a distance sensor, so this is the way. We're going to formulate a string here. Okay, so I'm going to make a string. Let me call it st equal empty string. So first I'm going to add what? ID, which is so I need to downcast distance sensor ds equal distance sensor s. So, and then this is ds dot get ID plus semicolon plus ds dot get what?
Name.
Get name plus ds dot
Right.
Brand.
get brand. Okay, let me go to the next line. st equal st alhamdulillah. عندكم الله يصلح بالك.
Yes, the get.
Okay, ds dot get value.
Get max and min.
Yes, plus ds dot get mean range plus ds dot get max range plus ds dot, is it clear? What is unit?
The same.
Unit here. Yes, and then we have now everything in S. We will do fw dot write st plus /n to go to the next slide. Okay, what we did here, we're going to do the same for air quality. Okay, I'm going to bring a line from air quality so we have the ID. We did not make the ID here.
Sorry. Yeah, we did this.
This is read. Yeah. So I'm going to cast to air quality.
We don't have main line. Yes.
Okay, and finally we write the value. That's all. And now we are done with the method write. Okay.
Professor, I have a quick question. Can you go back to the code?
Mm-hmm.
Can you just briefly explain line 130, 140 and 139? Because I'm always a bit confused when we do instance up and then the downcasting.
What is not clear here?
So first thing we do, we check that S is a distance sensor, right?
Yes.
And then if it is, we downcasting to it? Or?
Yes. To be able to access the different attributes.
So ds becomes a new object that will access.
Yeah, because if you do s dot get ID, you cannot find. The sensor doesn't have these attributes. Any other question?
I think so.